Hello, this is Dr. Mears, and today we are going to be learning about the midpoint and distance formulas in 3D. Let's first look at and investigate the 3D shape. Now let's look at our X and Y axes. Those are the ones that we're used to using. Those are the 2D axes. Down here, this is your X axis. So if we were going to be going from point O to point A, we would be on the X axis. Let's find the y-axis. Here's the y-axis. The y-axis is going in that direction. So if we were going to go from point O to point C, we would be on the y-axis. Now, we're used to looking at 2 dimensions because we're just working with x and y. So if we look at the, let's call it square, O, C, B, A, and then back to O, we would just be in the 2 dimensions. So this base right here, let me draw it in a little bit different, a little bit darker. O, C, B, A, back to O. That is just the 2 dimensions. That's where we were working with all last year. Now we're bringing in a 3rd dimension, which is going to be our height. We're now pulling this shape up, and we're giving it another dimension. That dimension is the z-axis. So if we were going to go from point O to point D, we're working on the z-axis. Let's put some numbers in here. So I'm going to say the distance between O and A, this is going to be 3, which means this point right here on the x-axis is going to land at 3. So this whole entire thing is 3. Okay, let's give Y some numbers. So this whole from O to C, let's make this 2. So C right here is sitting on that 2 on the Y. And then let's give it some height. So from O to D, let's say that's going to be 5. So D is sitting right here on the z-axis at 5. So let's label some points. Let's first start with A, okay, because it's just sitting on the x-axis right here. It hasn't gone out to the y, hasn't gone up to the z. So this point right here, when we label a point, we're going to label it as x, y, z, just like the alphabet. So for point A here, if we were labeling it as x, we know it's on the 3. Okay, that's where it is on the x. Now, has it gone anywhere for the y? Is it anywhere over here? Nope. So that's 0, comma. Has it gone up? Do we have any height to it? Nope. 0. So this just means that it's on the x-axis at 3. Let's try labeling point C. Point C, we can see, all right, well, is it anywhere near the x-axis? No, it's just sitting on the y-axis. So it is nowhere near the x-axis. X. On the y-axis, where is it? At 2. Does it have any height to it? Nope. 0. So 0, 2, 0. All right, let's do D. Hopefully you're catching on. So D for the x, no, is at 0. It has no x value. It has no y value. And Z, it's actually just up 5 units. And so those are how to label the x-axis point, the y-axis point, the intercept, and the z-intercept. So now we're working into intercepts, and this is how you label them. Let's say that we have a point that's not on one of the x, y, or z axes. That's not an intercept. Let's look at point E. Okay, let's label this one. We first start with the x. So we notice, is it 3 units over on the x? Yes, it's parallel to A. So we have to, in order to get to E, think about this like directions. In order to get to E, we first have to go 3 on the x. 3. Okay, that's x. Now what do we have to do? Now we have to, let's look at our y. Remember, our y is going this way. have we moved, have we gone in the y direction at all? No. So this is 0. We haven't moved over this way. It is completely parallel to A. And remember, A's value for y was also 0. X, y, and z. Okay. But have we gone up the z-axis? Yes. How many have we gone up? We have gone up 5. So Z's point is 5. So now we can label E as 3, 0, 5. Okay, let's try F, because now we have some values. Okay, so here we go, F, our X value. So now we can look, how far over do I have to go to get to F? How far over on my X? You're absolutely right, it's 3. Just like we did for our A and for our E. We're on the same X value for F. Okay. How about Y? How far out did I have to go to get to the F? Yes, you're right. I had to go 2 units. So for this Y, you're looking at how far I have to go over. Okay. And now, does it have height to it? Yes. How many did I go up? Yes, this is a 5. 5. See how these match here? So I had to go over 5. So F, we had to go 3 on the X, over 2 on the Y, over up 5 on the Z. Okay, hopefully you're catching on. That has been the investigation of the 3D shape. Now let's look at midpoints. Remember, midpoint is the middle point of a segment. So if we have this segment right here, and let's say that this is 10 units long, the midpoint would cut it in half. This would be 5 units, and this would be 5 units. It would be the middle point. Okay, so that's what we're going to find. What do we need to find the midpoint for? Let's look at our example. Number 1, find the midpoint of line segment EF. These little brackets just mean line segment EF. When E is 3, 0, 5, and look, we got that, 3, 0, 5, so we're talking about this, okay? And F is 3, 2, 5. Oh, we labeled that as well, 3, 2, 5. So what they want is they want the middle point between E and F. Where is that middle point? Here's our formula. It is just like the midpoint formula for 2D, except you're just adding on the Z value. So we need to add up the X's and divide by 2. Add up the Y's and divide by 2. Add up the Z's and divide by 2, which makes sense because midpoint is the middle point and we're cutting it in half. Just like I did here. I cut 10 in half, 5 and 5. Okay, so let's find the midpoint. So we're going to add the X's. Let's label this X, Y, and Z. X, Y, and Z. And I'm going to put little 1s there because this is the first point. X2, Y2, Z2. I'm going to put 2s there because this is the second point. This makes it easy because then I can just go, okay, here's X1, X2. 3 plus 3 over 2. Okay. Y1, Y2. 0 plus 2 over 2. Z1, Z2, 5 plus 5 over 2. Okay. Please remember, add first. Please add first. So 3 plus 3. So here we're going to have 6 over 2. 0 plus 2, 2 over 2. 5 plus 5, 10 over 2. And finally, let's reduce. 6 divided by 2 is 3. There's my lights. They never stay on for long. 2 divided by 2 is 1. And 10 divided by 2 is 5. So our midpoint of line segment EF equals 3, 1, 5. Let's check that out. Let's see if we actually end up in the middle. Okay. So remember, this is my X. So I'm going to go over 3. Boom. Okay. This is my Y. So I'm going to go up to, right, I was right. Okay, good. I'm like, okay, I was right. I'm going to go up to 1. Boom. and then I'm going to go over to 5. Which doesn't make sense here. Oh, nope, it's right. Just kidding. Okay, so we're going to go over to 3. I just had a moment of, oh my goodness. Okay, over to 3. And then we're going to go on the y value. This whole thing is 2, so I'm just going to go over. So remember, this is 2 here. So I'm going to go over to 1. Here's 1. Okay. And then where am I going to go? I'm going to go up to 5. Boom. And here is my middle point. Sorry for the dramatic pause there, but I was like, wait a minute, I don't want to end up in the middle of the box. I want to end up in the middle of the line segment. So there we go. We went over to 3, then we went to 1 on the y, and then we went up to 5 on the z, and that's where the middle point is, and we did it. Yay. Okay, let's find the distance. Now, distance formula is, how many boxes or how far or how many centimeters or meters does it take us to get from one point to another. So the distance between this point and this point is 10. Okay, we have to find the distance between E and F when E, we know 305 and F is 325. Now here's the thing. If we look from E to F, just in this picture, how far is it from E to F? Right here. How far is it from here to here? And I hope you said 2 units, because that's what it is. It's going to be 2 units. We can clearly see that. We went from 0 to 2, okay? But let's use a distance formula, because if we didn't have a picture, if it wasn't as easy to count, we are going to need some other method of finding the distance, which is helpful. Okay, distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So we're going to take the x values and subtract them, square it. Take the y values and subtract them, square it. Take the z values and subtract them, square it. I hope you realize that this is just the distance formula, except we have another dimension added on. Okay, so let's find the distance between E and F. So distance equals square root, parentheses. Let's label this x1, y1, z1, x2, y2, z2. And we're going to take x2, 3, minus x1, x1, 3 squared, plus, don't forget that parentheses, y2, 2 minus y1, 0 squared, plus z2, 5 minus z1, 5 squared. You're probably realizing we're going to have things canceling out, which is that's what happens, because we already know that it's 2 units. So this equation is not going to be too difficult to do. D equals square root. Please notice how I am following my equal sign down and I'm showing my work. Showing a formula is also good too, and I'm going to talk about that in a second. All right, 3 minus 3 is 0 squared, plus 2 minus 2 is 2 squared, plus, and I like to put parentheses around these because you never know who could be negative. D equals the square root of 2 squared, which is 4, so D equals 2. All I did, these are zeros anyway, so 2 squared is 4. I'm sorry, let me scroll down a little bit, and the square root is 4 is 2. And that's what we saw. So the distance of line segment EF is 2 units. And that's what we saw up here. We saw that it was 2 units. 1, 2, all the way to 2. But I wanted to show you how to use the formula and how similar it was when we do a 2-dimension distance. Okay, let's look at one more example. And this is where we don't have a picture. We don't know what it looks like. We could draw it out, but all I want to do is find the midpoint in length. We have formulas for that. Down here, I just want to say a hint for IB. The best way to show work and gain credit is to write down a formula, substitute the numbers, and then evaluate it. That's where you're going to get the most points, because if you get the answer incorrect, the scorer or reader is going to say, oh, wait, but they understand that they're finding distance. They understand what numbers to substitute in, and they're going to give you the most credit. Also, keep your work organized. Either keep the equal sign under one another. So just like what I did here, see how my work is organized? I worked down the page. Or if you like to work across, like you're writing a sentence, then just keep doing the equal sign across. They just want to see some organization. So knowing that hint, let's find the midpoint. So I'm going to label these x1, y1, z1, x2, y2, z2. Let's organize our work. Let's call this midpoint of line segment, what is it, AB? Okay. Let's show them the formula, x1, x2 squared plus y1, y2 squared, not squared, divided by 2, z1 plus z2 divided by 2. So we showed them the formula. We know what we're finding. Let's substitute our numbers in. 1 plus 3 divided by 2. For the y's, 2 plus 3 divided by 2. And for the z's, 5 plus 7 divided by 2. So now we know what we're doing. We know that we have a formula. We substituted our numbers in. Let's evaluate. 1 plus 3 is 4 divided by 2. 2 plus 3 is 5 divided by 2. 5 plus 7 is 12 divided by 2. And now it's going to be 2, 2.5, and then 6. You can keep this decimal. That's absolutely fine. That's absolutely fine. And then we can go back and say the midpoint of AB is 2, 2.5, and 6. There you go. Okay. Let's do distance. So now we're finding the distance of not EF. We're working on AB here, everybody. AB. Okay. Let's show them the distance formula. And I work down. You can work across, that's fine. x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And I'm just going to extend this. Make sure that this whole entire expression here is covered by your square root symbol. If they see that it's not, again, points might be deducted. Okay, let's substitute our numbers in. So we have x2, 3 minus 1. Oops. Going too fast here. 3 minus 1 squared plus our y's, 3 minus 2 squared plus our z's, 7 minus 5 squared. Now I evaluated it in, went down to the next line. Let's show them some work. 3 minus 1 is 2 squared, plus 3 minus 2 is 1 squared, plus 7 minus 5 is 2 squared. Now I'm keeping it in parentheses because this might be negative. And if it is, you need to put it in parentheses because the negative needs to be squared as well. When we have these numbers underneath, by the time you get to this spot where you're taking squares, all of these numbers, everybody, all of these numbers are going to be positive. You are going to have no negative numbers. We're dealing in distance. And if you come out with negative numbers here, you're wrong. So make sure you check all positives here. Here, that's okay. You can have negatives. That's fine. Negative's okay here. And I'm talking about a negative number inside. But when you square it, it's going to come out to be all positive because you squared. Okay? Check that. Because if it's negative, you're not doing it right. You did not put parentheses around it. Okay. That's my TED Talk. Let's move on. Square root 4 plus 1 plus 4 is 9. Square root of 9, you can do that on the calculator if you forgot how to do square roots, or if you know what number times itself gives you 9. So here's the square root button down here. It is a second key. So that's the square root right above the x squared, and you put 9. So now what number times itself gives you 9? You're right, 3 times itself. Notice there's no square root over there. That's another mistake people make. The square root disappears. All the square root is saying is what number times itself gives you this. And we found that. That's 3. So the distance of the AB is 3, and because it doesn't have any units, I like to put units, 3 units. Okay, so this has been finding midpoint and length in 3 dimension. Hope it helped.